Hello there, welcome. I'm an old guy and I do maths. Today we're going to have a look at the types of gradients that you're likely to encounter on linear equations. Principally there are two. There's a positive one which runs from bottom left to top right. This is our line here. The gradient is the number beside the x in the equation, y equals mx plus c. Let's just go to an example and you'll see how this works. So here we have a gradient, bottom left to top right. We've decided that the gradient of this is 1, so we put a 1 there. The principal thing to take away from this is that a positive gradient looks like that. It could look like that. It could look like that. But essentially it runs bottom left to top right. Now, the negative gradient does the opposite. It runs from bottom right to top left, and it's got a negative in front of it. So what we see here is the general equation of what might be a negative gradient for a linear equation. And here we have one on a little Cartesian plane. It intersects the y-axis at 2, which is why that 2 is there. The thing we're interested in, though, is the gradient. It's negative. Bottom right, top left, and the size of the gradient is 1. The slope is 1. Okay, so let's have a look at some of the odd stuff. So there are two principal cases here. One is where we have a zero gradient, which is when we deal with a horizontal line. Now it could be anywhere running through the y-axis, and it's got a gradient of 0 when it's flat. And the equation for this looks like this. It doesn't look like any other linear equation. Y equals 3. No x, no other number. 0 gradient. And here's the matching one that runs through the x-axis. This is a vertical line running through the x-axis, and again, it could be here, it could be here, it could be here. This has an undefined gradient. We won't get into why it's undefined just at the moment. Just recognize that it's undefined when it goes straight up and down. And the equation of this one is x equals 3. So the equation of this one was y equals 3 when it went across and through the y-axis. The equation of this is x equals 3 when it goes across the x-axis, up and down. Now, let's do a little bit of artwork with the yellow pad. So let's draw ourselves a pair of axes, y and x, and there's a line with a positive gradient. And that might have a gradient of 1. So that might be y equals x plus c. Okay? 1x plus c. Let's draw another line. This has got a larger gradient. So this might be, I'm not saying it is, but it might be y equals 5x plus c. Now you'll notice that in both cases the intercepts are down here in the negative territory of the y-axis. We still say plus c because it could be plus a negative number. We can write it like that. And just to make things a little different, we'll put a line through here. And this is still positive. It goes from bottom left to top right, but the gradient is going to be much, much smaller than 1. And so it might be, I don't know, we'll say it's a half x plus c. So what can you tell from this? Well, as the number beside x gets smaller, as long as it's positive, what happens is the gradient gets shallower and shallower. And the same is true for negatives. So we'll just run one through here. Y equals negative x plus c, and one more just to demonstrate y equals, we'll say, negative 2/3 x plus c. So you can see from this mess of lines that as a positive gradient gets shallower and shallower and shallower, the number in front of x gets smaller. We can put a 1 there just for demonstration purposes, so it goes from 5 to 1 to a half. And up here, we can put a 1 here. This has got a gradient of -1, let us say. And as it becomes shallower, it gets to be smaller and smaller and smaller. So if we had one that was really, really shallow like this, it might be y equals -1/4 x. Okay, I think that's enough lines on one page. Thanks very much for watching. See you next time.